So the talk today is keeping up with the dependencies. What I will be talking about today is starting off with an introduction to open source software and its implications to security. Then moving on to the different programming languages and their dependency lifecycle, and how like dependency management is kind of unique to each programming language and what kind of support structures are readily available. Moving on to how to factor in developer experience. You are designing a dependency management program, and developers are an integral part of it. So, how exactly to involve them, and how exactly to design a solution for them? Then I'll move on to how to sustain a good dependency process, and I'll discuss like different approaches to this, what kind of things to look out for, and things that are easy to mitigate and things that are gotchas. And finally, I'll talk a little bit about how you will measure success and failure of a dependency management program. And I'll factor in some of my experiences in trying to plan for one. And then we'll conclude with Q&A. So hello, as introduced already, I'm Dhivya Chandramouleeswaran. I work as a security engineer for Lyft currently. And previously, I have worked as a security researcher at Adobe and a software developer at SAP. It's kind of advantageous for me that I have both experience of a software developer and a security engineer. Though I'll admit that when I was a software developer, I was much less aware of security when I was doing my day-to-day things. But as a security engineer, I pay attention to like how a developer perspective affects program design and implementation. So this talk is going to be touching upon those things and try to share my opinions on what kind of points of friction that you could encounter when trying to roll out a dependency management process and how you could kind of prepare for them, and in which cases would you just be like, okay, this is a risk acceptance criteria, so let's just do that. So yeah, what's this talk about? So like I mentioned, working as a software developer and a security engineer, it's weird, but I have been involved with dependency management at each of the companies that I worked for in like different roles. In some of them, I have been part of like implementing a customized solution, or in some, it's been about planning like a whole process itself. So this talk is going to merge all of those experiences and try to figure out how like others can take away like experiences from that and try to design their own. Of course, this is not going to be like a one solution fits all kind of a talk. In my experience, I think whatever work that I have done, I have solved dependency management program forever. Just kidding, not solved at all, but at least try to figure out like what are all the pitfalls, and going to share them in this talk today. So yeah, what exactly is open source and how does it matter to security? Open source is kind of obvious. Everyone at some point has used them, come across them, troubled by them, and various other things. I think all of us at some point have heard about struts. It was making like conference rotation a couple years ago and still is, I believe. So yeah, open source is a thing, and it's been kind of a boon for developers because if you're developing a program and you are kind of stuck somewhere, a simple Google search would probably return you a library that somebody has written out of their passion and is probably maintaining it. But yeah, you basically have a library that does things for you and you include it in your program. For example, you want to write a web server, then you basically have a Python library that does it for you. All you need to do is like import it and invoke it and then handle it. So yeah, open source is pretty easy to integrate into your developer environment. However, when it comes to security, there are certain things that I have observed which kind of differ based on experiences, based on environments. But one common thing is the conversation always goes like this. A developer finds a library and the first category that they match up to on the usability is whether it solves their problem or not. And in 80% of the cases, this is, hey, I want to do this thing. Does the library do this for me? The other considerations like when was the last commit? How old is this library? Does the repository even have issues reported? what kind of developers are contributing to this particular library development, whether it has any licensing issues. Things like this I have observed are often secondary, and these usually come up as like critical issues for security or like other departments of the organization. So yeah, and usually in the conversation, if it goes well, there's usually someone with experience or has had painful experience before. Ask questions like, okay, how old is this library? If it's something like, yeah, it's 5 years old and the GitHub issue seems pretty active. There was a commit like 2 days ago, and it has a security label, and people seem to be contributing to it pretty rigorously. And the developer community has a couple of like recognized faces in it. There isn't some like anonymous person trying to push a PR and containing malicious code. So things like this are when things go well. But when things go bad, it's usually like a GitHub repo that was set up like 30 days ago and has probably a wrapper to a major library, and there is no like update sync between those two. So yeah, there are good and bad versions of open source and how it matters to security. From a security perspective, dependency, I would categorize them as any additional code that you want to call from your program. So when you think about it from an application security perspective, it would stand outside of your trust boundary. So it would not be counted in your threat model, or it would be put at risk for your threat model. And so the label you give them is basically external code that you're bringing into your runtime. Dependencies tend to be of two types, direct and transitive. Direct dependencies are ones that you usually find directly used in the program, but then transitive dependencies are those that direct dependencies call on. For example, let's say you have dependency A. What you would kind of list out in your requirements file is you need import A, but then what happens in the background, depending on the languages and the dependency manager that they use, is A would be depending on libraries B and C. In case of a like uncomplicated transitive dependency, you would just have A depending on B, B depending on C, and specific versions of it in particular. However, when it comes to a problematic case, what you would have is a circular or just a convoluted dependency like graph, which is A depends on a particular version of B, B depends on a particular version of C, but then you figure out that A also depends on a different particular version of C. So that's when you enter kind of the problematic area, and that's where like security needs to pay attention to. One other thing is dependency management is not just for application security, though it does feature majorly in application security because it is associated with the application. However, compliance and legal play an important part in this too. You could kind of use compliance and legal as the bare minimum checkmark on whether you're doing things that are necessary for like maintaining a good security hygiene or a compliance hygiene. But if you want to go one step further and maintain a good security hygiene and kind of have a long sustaining process, you have to combine application security, compliance, and legal requirements all together. And specific callouts here, you usually find dependency management under vulnerability management and external dependencies management. A straightforward case of this is the NIST cybersecurity framework, where you can find dependency management under VM and EDM. So going specific to the languages that I have worked with, Python, JavaScript, and Go, these three languages have one thing in common, which is all three of them have significant transitive dependency volumes. So if you include like 5 direct dependencies in your, and by dependencies, I mean libraries, and both are used interchangeably during this talk. So you have like 5 libraries, and what you end up seeing in your actual source code or your code bundle is you will end up seeing like transitive dependencies that those 5 dependencies pulled in. And this is common for Python, JavaScript, and Go, which makes dependency management and the associated vulnerability management pretty difficult for them. In particular, for Python, you have pip environment, pip env, and pip tools for dependency management. These are popularly used dependency managers, though there are many others that are available in the market. The one thing that Python does different or by default is you have project level load. So if you mention dependencies, then these are loaded specific to your project. Though you can definitely specify to be loaded globally. So that way, any project that you have in your system gets access to those dependencies. The way that the dependency manager loads in Python is breadth first loading, which is it will load all direct dependencies first and then go and look for transitive dependencies. You could definitely change the behavior to do it depth first, like it would do one family of dependencies first and then move on to the next. But that's an optional behavior and not the default. Python supports loose top level pinning, by which I mean it supports like ranges of version in your requirements file. So when you see the code as you have in your repository, you would see the requirements file containing something like requests and then greater than, let's say, 4.4 version. So when you have like greater than or tilde or caret, then this means you're not exactly specifying like the exact version that you want that the program is dependent on. Rather than that, you are describing which is the minimum version that your program is dependent on. This isn't much helpful in security, and I'll speak about this more later. But it does offer a greater level of flexibility to developers because all they need to do is like figure out what's the minimum level needed and forget about it. The runtime dependency manager would pull in the exact version that's available at the time. For JavaScript and Go, the behavior differs in loading because JavaScript, there's no default behavior as such. You could have both depth first and breadth first loading, so it doesn't really matter. For Go, it does explicitly support lazy module loading, which means you can pause if you don't want to include certain transitive dependencies. Of course, you're looking at like runtime breakage or things shutting down, but you do have an option in Go for lazy module loading. One thing I want to call out in Go is you also have proxy library, like proxy setup for libraries available, which means even if you're dealing with external libraries, you could make a proxy for them internally. So that way, the developer perspective for that would be that they are consuming libraries from an internal source rather than an external source. So yeah, that's about specific languages and their dependency managers. So a little bit about dependency lifecycle. So the way I see program and dependency management is that each version of a program or each like aspect of a program would be categorized as an immutable source. So that way, let's say if you're running a program today, then you're basically calling it version 1. And once it starts running, it should be basically immutable. That means you don't update the library when it's actually running, or you don't attempt to update when it's actually running. Rather than that, you keep a checkpoint on, let's say, a particular version, and you update the dependencies for that. The next available version is going to be different if an update is available or if a vulnerability was reported. But again, the semantic differences between two versions should be based on your commits and based on your updates. The actual runtime should be unaffected. And I explicitly call this out because there is the issue of the loose top level dependencies, wherein you don't mention the exact version of the dependencies that you're working with. As you get closer to runtime, you do have the option to lock dependencies. So you get to know exactly which version of the library is actually like running or executing in runtime. For security, you actually need this. And this is more useful to get more accurate results rather than the loose top level dependencies. So a dependency management program should ideally focus on tracking and communicating the changes between these immutable states. And they need to be as accurate as possible so that the developers can act upon it quickly and relevantly. Quick note on how language selection influences security. The main pain points when it comes to dependencies and how they affect like vulnerability management is to do with the language behavior itself. For example, I spoke a lot about transitive dependencies. The characteristics between like Go, Python, and JavaScript is in a way that Go has lesser transitive dependencies than Python than JavaScript. JavaScript, I'm sure like some of you have come across this joke or article where if you load like a single JavaScript library, you basically download like the entire system. So yeah, that's there. Moving on to like language-based security. This is something to do with like ready-made features that are available in the language itself. And I say this because it affects like how many dependencies do you actually pull in, and how many features are readily available in the language itself, so you don't have to pull in libraries. And in that way, Go was designed as a secure language itself. It has a lot of semantic security controls built in. One example is like the memory overflow, which is handled perfectly, asterisk. But yeah, when it comes to language-based security, you have Go, which is um, less riskier than Python, less riskier than JavaScript. Patch management across three languages, both major and minor versions are supported. But the one thing that I want to highlight is dependency hell is possible in all of them. Like none of these three languages have like built-in safety controls against dependency hell. Like you can convolute your dependencies as much as possible, and if you have the time, you can play around with them. So the advantages for all these three languages, and this is to do with like basic library or dependency management hygiene, is you can sign the packages. So that way you are preventing supply chain attacks. You can lock the dependencies, as I mentioned, as close to the pinned version of dependencies that you have. You can report the alerts accurately. And finally, proxy loading. Go modules has proxy loading available, which you can set up internally in your company, and you can make all the libraries available through that. For Python and JavaScript, there are open source libraries that are available that you can take advantage of. So yeah, road to dependency hell is paved with definitely security issues. Some of the anti-patterns that you can look out for and maybe address in training is forking it and fixing it locally. If the owner of the dependency is slow on updating a particular issue, then there is a behavior that like companies that use the dependencies do, which is they just correct it for themselves and things are okay for that state. But then in the next state, it ends up causing a lot of conflicts because there is no code to match for upgrades. The second one is abandoned dependencies in some branch. You could see that when you're dealing with programs or services that have not been maintained for a while. And what happens here is you will see like a file with hundreds of dependencies, which are basically unused, but they were just used during experimentation and not cleaned up after. Finally, copy paste corrected code. This is a pretty bad anti-pattern where you see a library, and the whole advantage of open source is that you see the code that the library uses. So in case you don't want to use the entire library, what you do is just pick and choose the code that is available in your program. This makes things difficult for security because you cannot track individual pieces of code. There are certain solutions that do that for you, but it's definitely not a scalable solution, and you're going to be vendor dependent on that. Quick note on the reactive versus proactive approach. So when you talk about a dependency management program, you could choose to take either a reactive, which is you don't want to change things the way they are right now, but you do want to go against or go after the different vulnerabilities that you see in the system, which would be reactive. The proactive approach is when you have flexibility to change the developer environment a little bit. And you're talking about like a lot of adoption, communication, and like campaigns to get developers to adopt to this approach. So reactive, the first step is discovery. So because you're not dealing with programs that you're intimately familiar with, you're dealing with just the after effects and not what is causing them. You need a really good asset management program. So what this means is you need a system that scans and reports the vulnerabilities accurately and doesn't give a lot of like frivolous results. You also need to check if it covers local libraries and folks, because there are a lot of solutions out there that do it for external libraries, but local libraries that you yourself maintain are a bit difficult, but they also need to be taken care of from a security perspective. Finally, does the language have a vulnerability reporting structure? I bring this up especially for Go, because Go is a pretty new language as compared to Python and JavaScript. And when you look at the vulnerability database for Go, it's pretty new. So it's kind of hard to determine if things are accurate when you have only like 10 results to look up. So yeah, if you're using languages that are brand new, take the vulnerabilities that are reported with a pinch of salt. yeah, you might have to perform like due diligence and check them if they are vulnerable yourself. The second one is matching. Matching is where you have a source of vulnerabilities, but you want to check them against your own internal dev ecosystem. Um, Unless your company is like following the programming language best practices by like each and every word, it's possible that you will encounter certain deviations in programming practices. For example, you could use Python pip tools, but then you can have your own customized version of pip tools, or you could have npm, but you could have like a version of npm or a flavor of npm with artifactory, or you could just be using like bitbucket and other things that are associated with that. So making sure that your dev ecosystem is able to match with the source of vulnerabilities is pretty important. The second is you want to check if this is matching with the exact dependencies or is it approximate. Finally, for mitigation, you want to see if a patched version is available yet. And you also need to have a contingency plan if there is no patch available. Like, do you just pause and not communicate, or do you look for alternatives? In a proactive approach, you try to understand the developer ecosystem. You try to understand like what languages developers are using and what kind of libraries do they go after. For example, if request is something that is super popularly used in Python, do you see the same behavior for other languages? And what kind of products or features are being built by your company? And what kind of libraries do you think might be needed for them? For example, if you're dealing with ML or like data analytics, then you might want to look at libraries that specifically cater to that. Keeping a pulse check on industry trends or patterns. This is kind of optional, and your developers will thank you for it if you do that. But let's say if there's a new language that comes up and developers are flocking to it, then you kind of want to be on top of it and say that, yeah, I have reviewed the security of this, or these are all the approved libraries for this new language that you're going to use. This is pretty controversial because this does add a burden on the security team. But what you could do is maintain a queue for anything new, which means if at a certain point you take state of things and you see that certain languages are being used, but let's say you don't want to like use a particular library, or something is banned, or it's a bad library, or it's like riddled with issues, and you want to put it in the banned list. So what you do is maintain a central repository where you control the languages and libraries that are being used, but you still have like a mechanism to allow like new libraries to be added, but only after a review. So this does place the burden on the security team, and you have to take bandwidth and the level of detail you want to go into this into consideration. So yeah, bringing in developers. So far I have been talking about dependencies, but as a security team, usually I'm not the one who is including dependencies. I'm usually the one trying to update them or trying to ask others to update them. So what happens from their perspective? This is pretty important if you want to have a working dependency management with dependency management program with like least amount of friction as possible, which is you do like a requirement survey and you get to know your user story. Um, Sample questions that I've shared here were from the requirement survey that I ran for developers. So this is where you would see what do developers think of a dependency management program? Like what's their perspective? It's not necessary that you have to go 100% off of the responses in this survey. Some tend to be subjective. For example, the question, do they like to see stats about their code or program? This is subjective. Like a lot of them wouldn't want to see like just the dependency stats. They would want to see static analysis reports, or they would want to see code quality, not just dependency. But when you're talking about a dependency management program, these kind of things are good to have, but not like required to have. One thing that is important here is how are the test cases structured. This is where you do need developer input if you don't have like automation and process, because you want to see like how exhaustive these tests are. Are there enough unit or regressive tests that catch things that are not updated or things that break the system? These four questions are pretty important in terms of like the security team and developer relationship, which is how would the developers like to view the dependency alerts? Would they like to see an email? Would they like to see on Slack? And then the second one is there a clear chain of escalation in case of an incident? Like if an incident is reported, like in the case of struts, Does the security team have the autonomy to go and update everything, or do they have to reach out to developers and ask them to do it for them, or like invoke them for helping out in updates? The next one is tracking status. This is particularly useful when you're talking about dependencies that don't have a patch version yet, and you kind of want to wait for a while before it becomes available. So that way, you don't want to forget that there is a vulnerable dependency that is still there. So how do you keep track of this? Do you keep track of it through Jira? And if you do, then what kind of SLAs are you looking at? Do you follow like a conventional 30, 60, 90 day, or if you see a critical vulnerability, do you take it like a 2-day ETA, or you do it by a case-by-case basis? These are all the things that developers are kind of ambiguous about, and it's good to have these nailed down when you are talking about a dependency management program. Now, coming to the sustaining a good dependency management process. So far, what I have talked about, there are multiple resources that are available that have spoken about like what a good dependency management should look like, how different languages handle it, and what kind of issues there are. When it comes to like long-term sustaining a good dependency management process, there are certain surprises that I encountered, which I will share now. There are four main contingent areas which I experienced, which was first, when I went into designing this, I thought 100% automation was possible. However, 100% automation isn't possible right off the bat. You have to work a lot and like sort out the kinks before you could look at 100% automated solution for this. The second is expect opposite trends post program rollout. And by this, I mean when you roll out a dependency management program, you would expect to see vulnerable dependencies going in a downward trend. But what you would actually see is it would increase a bit, like the volume of reports would increase a bit. And if you have like really obsolete services or programs running, you might also run into like the initial speed block where you are dealing with updating transitive dependencies that are 5 years old, and you're kind of jumping between versions 5 and 10. That's definitely going to take a lot of time and a lot of hand holding, which will initially be discouraging, but yeah, you have to reset your expectations for that. The third is this cannot be offloaded to developers completely. Security team does need to do their homework on certain things. Though you can, the program could be designed to involve developers more, maybe 50%, but security team still needs to own like the supply chain part of it, wherein they would cross-check if the vulnerability reported is actually accurate and whether there are compensatory controls available. The last one is plan to handle uncertainties is crucial. This may not be written in your like dependency management program, but think about how you would handle vulnerability like struts that were reported tomorrow. Would it be possible to like resolve everything within 3 hours if a patch is available, or what kind of problems do you see happening there? And do you think it's good to have a process in place, and what kind of written agreements do you have between security team and the developer team? So yeah, talking about implementation, this is pretty straightforward. Any dependency management program implementation will have three parts. One is discovery, second is triage, final is mitigation. All these three things can be external, could be automated. There are multiple solutions available. For example, for discovery, you have white source NBD. For triaging and for mitigation, you have ready-made solutions like Dependabot, OWASP, dependency check, Sneak, and you have like multiple open source scripts available that can do this for you, published by various companies. So you can look it up. But if you want to have, you can have a customized tool as well. The most important thing I want to call out here is asset management and accurate reporting, and how this would help a lot in maintaining a dependency management program. If you have good asset management, which is you know what your requirements file are, and you know like you have a good accurate source of vulnerability, and you're able to match both together, as in you can go to the level of code detail and see if the affected code is actually part of your program. That nails down the accuracy pretty perfectly. The second one is agreeing on severities. This came as a bit of a surprise to me, because I thought if a vulnerability was reported as critical, then that would indeed be critical. But taking in developer perspective, you could see that um, for cases where a critical vulnerability is reported, it's possible that your program might not be exploitable to that. Like the actual code that is vulnerable might not even be part of your code base. So if the developer team is resource trapped or they do not have time for it in this particular sprint, then you might need to negotiate with them on what kind of compensatory controls are available, whether it's actually affected or not, and when do you want to like track it back, and whether we can agree on the severities being lowered down or leveled up. So yeah, challenges faced, quick recap. So yeah, starting troubles. If you are dealing with like a lot of old code, program dependencies that haven't been updated for a while, plan for some time to like sort those out. You might want to take baby steps on that by minor version than just jumping the major versions. And rather than focusing on just that, try to understand like what percentage of the overall dependency update is the like old update consists of, and then plan accordingly. Handling transitive dependencies is again language specific. If you have good like programming hygiene, then this is kind of taken care of even before it comes to runtime. But make sure that whenever you try to update a vulnerable dependency, you do not introduce dependency hell for the developers. Make sure you have adequate testing. So you have unit and regression testing that tests for each and every use case, and specifically for dependency updates and rolls back if there are any conflicts that are identified. The fourth point is alert fatigue, which I want to draw attention to. This happened to me where I signed up for an external program which reports a lot of vulnerabilities, but what I ended up getting was like 10 email alerts every day. And I find myself thinking like, okay, is my program really vulnerable, or is it just like the same alerts that are coming to me every day, or is it a different one? Is it even relevant to me, and things like that. So when I start questioning an alert that comes to me, it reduces the response time. It requires additional time for me to actually validate the results, and like puts the burden on the developer team to actually do this stuff for the security team. So make sure that your alerts are as granular as possible. And when I say granular, this means one, whether the vulnerability is exploitable. Two, whether a patch is available or not. Three, if a patch is unavailable, then is there a compensatory control available? And by this, I mean, do you have like an alternate version of a library that could be used? Or could you just write it in-house in like a matter of like 2 days or something? And make sure that you have a good feedback loop. So even if you see like a particular team or developers not addressing um, like a bunch of alerts, then you can contact them and ask them like what's the issue that they are facing and what kind of changes that you have to make in your process. Loopback failure is when a patch isn't available. Like I said, you create a ticket, then you shouldn't forget about it. So make sure your automation covers this particular issue. Balancing automation and manual work. Again, try to understand that this cannot be 100% automated right away. Long while, once you have your program hygiene logged up, you can probably think about automating it 100%. But again, when a company tries to keep up with innovation and try out new languages and libraries, especially when you're dealing with experimentation, it's kind of hard to make it 100% like automated unless you're trying to like stifle something. Sprint estimates is something, again, you want to consider when you're thinking about the developers. You want to think like how much time do they have cataloged for, let's say, patching or dependency management? Or is this something that is automatically taken care of when like a base image is being created? Or yeah, try to understand your developer ecosystem. Finally, as I mentioned before, inadequate vulnerability data, which is try to understand the language maturity and what kind of alerts you might get from them and set your expectations accordingly. For measuring success and failure, this is what you use to communicate to non-security folks or like in general for yourself to understand how you're doing in your process and also to like understand success and failure. There are two key results, which is team-specific and infra-specific. Team-specific goals would help you in other aspects of application security. For example, if a particular team has a lot of vulnerabilities, you kind of want to need to address that in training. These are a few checkpoints to monitor. If you have a dependency management program, do check if you are able to answer these following questions, because these are pretty important if you have like a robust dependency management program. Checkpoints to consider. These are nice to have, not absolutely necessary to have, but it will definitely ease the relationship between the security team and the developer team and make it more visible that you're working for them. So what kind of developer training is required for dependency management? What kind of issues do they reach out to security on? Like, do they reach out to you for maintaining transitive dependencies? Do they complain to you that you broke their CI/CD process? Things like that. One important takeaway from this is how would you rate the security maturity? Like, do you see a particular team consistently updating their libraries? Then you probably give them green. And if you have something like security champion program, then they may be good candidates for them. So these are good signals for that. And finally, one thing, as I mentioned, the goal of tracking and communicating like the state of the program between immutable versions. So you also need to loop back to that and check how easy is it to make an immutable image with safe dependencies to begin with. If that itself is the problem, then yeah, you should probably go back to like checking your CI/CD process and seeing if there's anything that needs to be addressed there. So yeah, quick recap, three things. First one, when you're considering implementing a dependency management program is identify trade-off points. Depending on your company and depending on your team, posture, bandwidth, etc., you might want to consider non-negotiable and negotiable items when you're considering the program. The second one is expect initial setback. Your metrics initially would not look the way they are meant to be. So make sure that you sort out the kinks and then start paying attention to the metrics. Finally, if you're choosing an external solution, choose them wisely. Organizational metrics are something that are pretty important. Developer metrics are also important, but they kind of lose the bird's eye view on that the security often needs. So make sure that whatever solution that you're considering, there are available APIs that both security and developer could experiment with. So yeah, that's about it. Thank you. Time for questions.
All right, Divya, we have two questions for you. First, how do you deal with slow updates that you really need to fix? Like if I made a pull request, but I'm still waiting on a maintainer who may not merge it until later, how do I deal with those kind of security problems?
Yeah. So there are two approaches to this. One is you enter the arena yourself. You try to like bring in other developers that you know of who are familiar with the ecosystem who can approve it for you, or you can try to ping them. And of course, that's the like the nagging way of doing things. But if let's say it's a critical update and you definitely want an updated version available, what you could do is try to patch it in your code, but try to make it like your own local library version. And this is what I was referring to as the proxy. So the library that you would actually call with the corrected code is your proxied version rather than the external version. And then once the maintainer responds to your PR and once that's fixed, then you can pull back the next available version for that. So that way you wouldn't cause code conflicts.
The next question, Divya, is if a single node app with 10 direct dependencies brings in 1,000 total dependencies, is it even worthwhile to approve of libraries?
It depends on how important those 10 libraries are and whether you can deal with those 1,000 dependencies. If you follow the proactive approach, that library is like those 10 libraries or whichever libraries are pulling in the most transitive dependencies should be in the banned list anyway. So if you go the proactive approach, then you're kind of not making it available and you want to look for alternatives. But if you are coming to a point where there are no alternatives available and you definitely do want to use them, all you can do is like ramp up your asset management and discovery solutions so that they can keep track of all 1,000 transitive dependencies. I mean, it comes to the trade-off that I talked about, like the negotiable part, wherein at that point you kind of transfer the risk to the developers that do you want to like keep up with the 10 dependencies or not. So there are different approaches you can take, but it depends on your risk posture.
Divya, thank you so much for your talk today and for being a part of Loco Moco Sec. Thank you for answering questions for us, and have a wonderful day. Thank you again.
Thank you so much.